Hey everyone, and welcome to day 3 of my research journey. Today we're going down a slightly different path, but one that directly ties back to one big research question. How do different types of dietary carbohydrates influence the severity of SIBO symptoms and gut microbiota composition? To explore this, I'm analyzing an AI-powered approach to understanding how the body digests carbohydrates. An approach originally used in diabetes research, but one that could offer major insights into gut health too. When we eat carbs, they're broken down into glucose and absorbed into the bloodstream, or in some cases, not absorbed at all, leading to fermentation by gut bacteria. For people with SIBO, this fermentation can cause serious symptoms: gas, bloating, and even malnutrition. And guess what? The rate and type of carbohydrate digestion plays a huge role in determining whether carbs feed you or feed your overgrown gut bacteria. So today's dive into AI and carb digestion isn't just techie, it's directly connected to the biology behind SIBO. The first paper I reviewed comes from the journal Sensors, and it tackles a different but related problem: predicting blood glucose levels in people with type 1 diabetes. These patients need to dose insulin based on how quickly their bodies absorb carbs, a process affected by the type of carbohydrate, which is exactly what we care about in SIBO too. Here's the challenge. Not all carbs digest the same way. Simple sugars like glucose get absorbed fast, while complex carbs or fiber take longer, or bypass digestion entirely and become food for microbes. In both diabetes care and SIBO research, modeling this digestion process is key, but individual differences make it hard to use one-size-fits-all equations. The researchers created a hybrid AI model. They combined psychological knowledge about how insulin and carbs are absorbed with deep learning to predict how blood sugar will respond over time. Instead of just feeding the model raw food data, they estimated personalized carbohydrate absorption curves, basically how each person digests carbs over time. These curves were optimized using a technique called genetic algorithm. Here's where it gets exciting for our SIBO question. If we can model how different carbs are absorbed in different people, we can start to predict who's more likely to have unabsorbed carbs fermenting in the small intestine, fueling SIBO symptoms. As I dove into this paper, I spent time annotating the sections on absorption curves, which honestly were fascinating. Here's one of my marked up visuals on the right. These curves map how insulin and carbohydrates act in the body over time. I like to think of them as a digital fingerprint. Simple carbs, like glucose, spike fast, but others, like resistant starch or fiber, have a flatter curve or barely absorb at all. I made a ton of margin notes in this part. Check out the section I highlighted on the right as well. The authors use a genetic algorithm to evolve the best fit curve for each person's digestion profile. This really stood out to me because it personalizes digestion in a way that's rarely done. By stimulating generations of adjustments, the algorithm adapts to the data and finds the curve that most accurately reflects a person's unique carb absorption. This could help us understand not just how fast we digest carbs, but also how much might linger in the small intestine where it could cause SIBO symptoms. Then they plugged those curves into a long short-term memory neural network, a type of AI especially good with time-based patterns. The result? Much better predictions of future blood sugar levels. If this AI can learn how individuals absorb carbs over time, imagine adapting it for SIBO studies. We could model how certain carbs escape digestion and end up in the small intestine. We could even test how microbiome composition alters those curves, potentially predicting which patients will respond best to low FODMAP diets or prebiotic interventions. This study didn't use microbiome data, and the patient data was simulated, not real world. It also didn't link carb absorption to GI symptoms directly. That's where future research, like ours, can step in. What if we paired absorption modeling with SIBO symptom tracking and gut bacteria profiling? This is the kind of interdisciplinary science that could transform personalized nutrition and SIBO treatment. AI could help decode which carbs are gut-friendly for which people, paving the way for precision diets that support gut health instead of aggravating it. So, to sum it up, AI can model how individuals digest carbs using personalized absorption curves. These models could explain why some carbs worsen SIBO symptoms while others don't. And the next frontier, combining these models with gut microbiome data to predict not just blood glucose, but also gut reactions. So what do you think? Could tools like this reshape how we treat gut disorders like SIBO? Have you seen other cool uses of AI in nutrition or microbiome science? Drop your thoughts in the comments below. In my next episode, I'll be diving into the gut microbiome directly, looking at the role of specific bacterial species in fermenting different types of carbohydrates. Thank you so much for listening.